Calculus students, in this video we are going to talk about alternating series error bound. But before we jump onto the alternating series, let's take a look at that we can actually find the sum. Which series we can actually find the sum? There is only one series where you can find the sum is a geometric series. That's the only one you can find actual sum. The formula for the sum is a first term divided by 1 minus common ratio. This is the only one you can find the actual sum. Now, sometimes you can approximate the sum based on if we know where the partial sums are going. So, limit of the partial sum, when limit n approaches infinity, partial sum is some number, then we can say, we can approximate that the actual sum is that number. Now, many times we can approximate the sum. The only one series we can approximate the sum is alternating series. So let's take a look at the alternating series. What is alternating series and why we can approximate the sum? So quick review. Alternating series has an alternator, -1 to the n, a n. So let's take a look at this most famous series here where -1 to the n plus 1 over n, if we expand, we get all these terms. This is a very famous alternating harmonic series. Without alternator is a harmonic series, diverge. With alternator, it converge. But let's take a look at what's happening to all the sums. So take a look at this picture here. These are all the partial sum. 1 is here. 1 minus 1/2 is a half. So this is 1/2. 1/2 plus 1/3 is this number here. If you subtract 1/4, that's the one. So these are all the partial sum. Clearly the partial sums are headed to some limit in the middle of this point. So this is, we can see that the partial sums are jumping up and down, it collapses and it comes up to some number. Each jump is smaller than the previous one. Each jump is smaller than the previous one. So for example, if I take let's take a look at the sum of 5 terms. If we stop at sum of 5, how close will be my answer? So I'm going to show you here. If I stop at 5, 1, 2, 3, 4, 5. If I stop at 5 terms, how close will be my answer? My answer will be this close. You can see that the next term and the actual answer, this will be the error. So alternating series, error is always the next term. If I use 6 terms, you can see this will be my error. That's the, so take a look at picture here one more time. The 6th term is the error. If I stop at 5th one, 6th will be my error. So what happened if I stop at 11? What will be my error? Well, the 12th term will be my error. If I stop at 100 terms, if I need to take 100 terms, how close will be my answer? Well, 101st will be my 101st term will be my answer. So this topic is very important, but not so difficult. Always the next term will be the error. Error is always absolute value. So I'm going to jump into our packet, which is your page number, I think it is page number 14. This is page number 14, alternating series remainder. So let's talk about the vocabulary words. Remainder is the same as error. Remainder is the same as error. How far we have to go so that our remainder is the error. Then actual sum is a remainder, is an error, is always less than the next term. Remainder is always less than the next term. So if I look at this is, I'm just explaining here, this is the error or remainder, you can say. This is the actual sum, which we cannot find out. This is the partial sum, nth term, like partial sum. And this will be my next term. That means where I stop, the next term is the error. Remainder error is always less than the next term. We are looking for the maximum error here. So that's what the whole purpose is, less than or equal to. But before we jump into, we must establish the conditions of alternating series. Conditions of alternating series is terms are alternating, decreasing, and have a limit of 0. You must include the conditions. Then we can say the series has a approximate error, and then you can find the interval. This is the actual interval where my sum lies. That means my actual answer sum is approximation and plus minus error. Approximation and plus minus error. We don't really have to write the set notation. You can also write using a inequality. So let's talk about the actual sum will be partial sum minus error and partial sum plus error. That's what the actual sum is, plus minus. So, and that's what the inequality. Many times they ask you find the interval where my actual answer will be. So this is all about approximation and it's all about remainder. So let's take a look at one example which is on your page number 14. Okay, so I'm going to, let's understand the question. Approximate the sum using first four terms. So all you have to do is expand and write the first four terms. Approximate sign, squiggly sign. If you don't write the squiggly sign, if you write equal to sign, there is no penalty in the AP exam, but it's the best practice is to write approximate sign. You don't have to go to this answer, just stop. Do not simplify, you just keep it factorial, just stop. That's my approximation of the sum, and you normally we write S4. S4 is sum of 4 terms. Do not simplify, just stop, leave like this. Okay, so let's read a B. Use alternating series error bound to show that this approximation differs from the actual value by less than 1/100. What this means is find the error and show that error is less than 1/100. So understanding is more important. Differ means difference. Difference is the difference between actual value and the sum is the, of course, error. All you have to show that it's less than 1/100. So if we expand this 4 factorial, what will be the 4 factorial? What will be the 5 factorial? So here I'm just you must include the conditions of AST. This is a must since the terms are alternating, decreasing with a limit of 0. Remainder is the same as the error. You don't have to write all of this. You just have to say that the remainder is that you don't write all this also if you are not sure how to write. You just establish that the error is less than 5th term. All you have to find the 5th term. You do not have to write all this if you are not sure. All you write is remainder is the error is the less than 5th term. Less than or equal to, should be less than or equal to. But here this is less than, so that's fine. 5th term. But how do you know which is the 5th term? And you have to show that the 5th term is less than 1/100. So error is less than 5th term. 5th term will be 1/5 factorial. Remember, you don't have to worry about the positive negative sign. So first, second, third, fourth, 5th term is 1/5 factorial. 5 factorial is 120. 120 is less than 1/100. You must show that this step is you must show. So if you don't know, don't have to write this down. You don't have to. It's just in explanation. I'm showing you this, that what this error is. Error is next term, which is less than 1 over 100. You have to show the inequality because it says that show that it is less than. So you have to show that the error is 1 over 100. So it's not that difficult. It's pretty straightforward. You just have to establish the condition. The next term is the error. Next term is the error. Now, C is where you will need a calculator. Show that the sum cannot be 0.7. So C is the only part where you need a calculator. And the purpose of calculator is to add all these numbers, which is 0.625. And to show why sum cannot be 0.7, you need to find the interval where actual sum lies. So that's what the interval I was talking about on the previous slide. So think about this is a sum of the 4th term minus error and sum of the 4th term plus error. Error is 1 over 120. So S for minus 1 over 120, S for plus 1 over 120. That's where my actual sum. So this is the portion where you are allowed to use calculator, and many times this is on the multiple choice calculator section of the exam, where all you have to do is save. This is store in value and 0.625 minus 1 over 120 and 0.625 plus 1 over 120. And this is the one you can see that my actual answer will be somewhere between these two answer. So obviously 0.617 and 0.633, somewhere between these two. So 0.7 is too big. And to show that y answer cannot be 0.7, you have to just add, subtract, and show this. You must include, one more time I'm going through, you must include the conditions of AST. You must include conditions of AST. So let's take a look at another example here on the other side. Okay, so here the format is slightly different. Let's read. Determine the number of terms required to approximate the sum of convergent series with error less than 0.001. 0.001 is the same as 1 over 1000. They are not asking you to find the sum. They are asking you how many terms do you need. Think about how the calculator works. How do you round to the nearest 1000? How many terms do you need so that your answer is round to the nearest 1000? We don't need 4 or 5 digits. We just need 3 decimal point closest answer. How many terms we need? So the best practice here is, again, you must write the conditions. Series has the terms alternating, decreasing in magnitude, limit of 0. You have to begin with this. Then only you can say error is less than. We can prove that the error could be the next term. So the best way to do it is expand the series and find which term is less than 0.001. You do not need a calculator here. We are approximating, and some knowledge of fractions needed. So let's start expanding. If I expand starting with a 0, 0 power gives me positive 1, 0 power gives you 1, 0 factorial is 1, 0 factorial is 1, 0 factorial is 1. Shouldn't be writing that 1 factorial here. So 0 factorial is 1. There should not be factorial here. Okay, so then the second term n is 1. So that's a negative 1. 2 to the 1, 1 factorial is 1. So I just wrote down all these terms. Now look carefully. Which term is, just look at the denominator. Which number is more than 1000? So this is 2 to the second, 4, 4 times 2, this number is 8. This is 8 times 6. Remember factorial is, so 8 times 6. This is 16 times 6. 4 factorial is 24. And here, let's take a look at these numbers here. which terms is more than 1000. So clearly this number comes out more than 1000. You can say 12 times 3, 36. 12 times 30, you can approximate 12 times 30 is 3600. This is roughly 3600. So you need 5 terms. Sixth term is, you don't have to simplify this. You can say that sixth term is less than 1 over 1000. That means you stop here. You stop here. This number comes, this is more than 1000, and this is 1 over. So we need 5 terms. So that error is this. These questions are pretty straightforward. All you have to do is write the conditions, expand, find out which one is the more than 1000 and how many terms we need. So you may want to pause this video here and try the next example. Try the next example, which is very similar. Now it's a coincidence that you get the same answer sometimes, but I want you to practice how do you expand and practice writing the conditions. So pause the video here and find out how many terms do you need. Okay, so since series has terms alternating, decreasing in magnitude, this is a kind of a mantra here. You are going to use it all the time in the series unit. So let's find which term is less than 1000. Expand. 2 to the 4, 3 to the 4, 4 to the 4, 5 to the 4. The good news is here you don't have to worry about the positive, negative. All you are checking magnitude. You are checking magnitude. So 4 to the 4 is 16, 256. This is 625. This is 1296. So clearly you stop here. And let's check it out. How many terms do you need? Oh, this is a typo. This should be 625. 5 to the 4th is 625. So sixth term is clearly less than 1 over 1000. So we need 5 terms. This is a purely coincidence that you get the same answer 5 terms, but not all the times you get the same. So for assignment, you are going to work on this problem, which is your page number 16. Page number 16. Please, please, please read question. What they are trying to, this one says differ. Differ means find the error. Here, number 2 is asking you, number 1 and 2 is asking you to find the interval as well. Find the interval as well. So that's where you could use a calculator, and the interval is actual sum. This is approximation minus error, and approximation plus error. So that's what your sum is. Practice on these 5 problems. They are really, really good examples. And I'm going to post the answer key along with this video in the assignment, and you can compare your answer. So overall, we are doing error 2 times in series unit. This is the first one, which is alternating series error. Thank you.